Hello everyone, my name is Benjie and I love GraphQL. GraphQL is amazing, but I have a confession to make. I hate resolvers. I've always hated resolvers. The GraphQL language is declarative, and yet resolvers were not built to leverage this awesome capability. Instead, they turn execution into a procedural, layer by layer, field by field, item by item approach. To my mind, resolvers are very much a minimum viable product approach to execution. They're simple to understand and to specify, but they punt things like solving the n+1 problem into user space, requiring schema designers to remember to use abstractions such as data loader to achieve acceptable performance. And they rule out entire classes of optimization strategies. As I grew to learn the GraphQL specification, I realized, of course, that we don't stipulate that we must use resolvers at all. One paragraph, right near the start of the GraphQL spec, states, conformance requirements, expressed as algorithms, can be fulfilled by an implementation of this specification in any way, as long as the perceived results look equivalent. We stipulate they must look like that's executed. That doesn't necessarily have to actually do on the side. So long as the observable result is the same, do whatever you want. I'm here today to say, step aside, resolvers! There's a new way to execute any GraphQL operation. The working title for this new project is Graphast, and it works by taking your GraphQL operation and compiling it into an execution and output plan. The output plan is a straightforward mapping from the data that we retrieve through the execution phase to the GraphQL result that we want to output for the user. So we'll skip over that. Mostly what we care about is the execution plan. We build the execution plan by mostly following the execution algorithm in the GraphQL specification. However, we do this before actually executing. So we're not dealing with concrete data, unlike we would be in the spec. Instead, we're dealing with what we call steps that represent this future data. When it comes time to execute, a step is quite similar to data loader in that it accepts a list of inputs and it returns a list of outputs. Batching is built into the very heart of Graphast. Whereas a field in a traditional GraphQL schema would have a resolver, in Graphast it would have a plan resolver. The plan resolver has similar looking code, as you might be able to see from a glance. But again, rather than dealing with concrete runtime data, it's dealing with future data, these steps, which we represent with a dollar symbol in the code on the right. By walking through the selection sets and calling the plan resolvers at each stage, we can build out a plan diagram, like this one, that expresses what needs to happen. Now, this plan diagram is not the final thing that will be executed. This is just our first draft. The Graphast system will go through each step in the plan diagram and give it a chance to deduplicate itself, to optimize itself, and to finalize itself. These are the three main lifecycle methods and that these steps may implement. Deduplication allows similar steps to be amalgamated to simplify our plan diagrams. Optimization is the main phase, the most critical one for performance, and it allows steps of the same family to communicate with each other and pass information between one another. For example, if we were dealing with the Stripe payment API, we might have a GraphQL field that fetches the customer from Stripe. And then in our query, we might have a child field of that that fetches the subscriptions for the customer, and then various fields below that. When the step responsible for getting the subscriptions is being optimized, it could determine that its grandparent is pulling data from a Stripe customer, and thus tell the customer step to fetch the subscriptions at the same time. Stripe has a feature called expanding for this. This would make the subscriptions fetching step redundant. So as the last action in Optimize, it can replace itself with a step that simply extracts the relevant data from the customer response. This way, we now only need one round trip to Stripe to get all the information that we require. Finally, we have the finalize method. This is typically unused for most steps, but it gives the step a chance to prepare for execution, to do something that only needs to be done once. For example, it might be used to compile an optimized JavaScript function to execute its action more efficiently. Or it might be used to prepare the final SQL or GraphQL query text just one time. Steps are designed to be something that you can implement yourself, much like you would with a data loader callback. They're a little more powerful than data loader and have these optional lifecycle methods that we just discussed. But in the simplest case, all they need is an execute method that takes a list of values and returns a list of values in the same way that a data loader callback does. We also have a number of optimized, pre-built steps that you can use to handle common concerns, including load 1 for batch loading remote resources similar to data loader, or each for mapping over lists, or access for extracting properties from objects. And we're building out more optimized steps for dealing with particular concerns. For example, issuing HTTP requests, sending GraphQL queries, or talking to databases. Ultimately, our intent is to use these steps to pass additional information to your business logic layer, no matter what that is, so that it may execute its tasks more efficiently. Just like GraphQL helps eliminate over and under fetching on the client side, Graphast helps you eliminate it on the server side. For example, if your business logic is implemented with an ORM or something like that, you can use this additional information to perform selective eager loading to reduce database round trips. If your business logic is from an HTTP API, you could use this contextual information to dictate which parameters to pass, better controlling the data you're retrieving, reducing server load and network traffic. And since Graphast is designed around the concept of batching, you never need to think about the n+1 problem again. It's solved for you, out of the box, by virtue of how the system works. Just like with GraphQL resolvers, Graphast plan resolvers are intended to be short and only express what is necessary to communicate between GraphQL and your business logic. And despite their pleasant ergonomics, they unlock much greater efficiency and performance than resolvers can. Graphast has been built from the ground up to support all of the features of modern GraphQL. Queries, mutations, subscriptions, polymorphism, and even cutting-edge technologies such as the stream and defer directives. And it's backwards compatible with existing GraphQL schemas, so you can use Graphast to execute requests against an existing resolver-based schema and then migrate to plan resolvers on a field-by-field basis. And if you already use data loader, then migrating to using Graphast plans should be very straightforward. We're hoping to release an open source version of Graphast under the MIT license, the very same license that GraphQL.js uses, in the first half of 2023. To be notified when we're ready, please enter your email address at graphast.org. If you'd like to help me continue to invest time in projects like this, please consider sponsoring me on GitHub Sponsors, and you may even get early access. Feel free to reach out to me with any questions. Thank you for your time, and I hope you're as excited about the future of GraphQL as I am. Thank you.